All right, so this is the problem that we are looking into for the calculation of the peak output voltage and the PIV rating of the diode. So this is for the circuit we just discussed, which is the center tapped full wave rectifier. So I want you to go ahead and calculate the peak output voltage and the PIV rating of the diode. That is correct. Yep. Rectifiers are for AC to DC conversion. So from the circuit perspective, this is how it is going to look like. Again, when you see the third terminal like grounded like this, that's automatically a center tap transformer right there. So the turns ratio is given as 2:1. 100 volts is applied. Again, that too, it's a peak voltage. So this is the circuit perspective of the same word problem that is mentioned up there. So either you see the statements like that given, or you will see a simply circuit something like that shown. So it's asking for the peak output voltage. So it's asking for the voltage which is the peak at the output. So peak output voltage, and it is also asking for the PIV rating of the diode. Again, as always, you carefully check what type of rectifier it is referring to. And look for subsequent formulas. Again, remember that same as before, if an RMS voltage is given, you always convert into peak. But in this example, the peak voltage is given to you already. So we can just start using from that. Yeah, multiplied by 1.414 or divide by 0.707. It's a DC. It's not a DC voltage. RMS is not a DC voltage. It's equivalent to the amount of heat generated in the DC voltage when you use a DC voltage. So it's not a DC voltage. The average is DC equivalent. RMS is in relation to the heat generated in a component when you use AC versus a DC. So it's a DC equivalent of the heat generation. So what is the formula for V peak out for the given circuit? So it's a V peak secondary. So that means the secondary voltage of the transformer, which should be in the peak, over 2 minus that's 0.7. So this is the formula for the center tap transformer with of course it's a full wave rectifier. So we got to find the secondary voltage. Since the primary voltage is given as 100 volts, so remember that this is only peak voltage, but that too, this is only the primary voltage of the transformer. So for secondary, so remember what we do for secondary?
use the ratio.
So you first starts with the secondary value divided by the primary, which is the 2. So it's 1/2 times whatever the primary voltage is, which is 100 volts. Again, everything should be in peak. So this should basically 1/2 of 100, which would be 50 volts. So you come back here, and according to the formula, it's V peak secondary over 2, which is 50/2. So that would be 25 subtracted with one of the barrier voltage, that would be 0.7. So the result would be 24.3 volts. So that would be the peak output voltage. Again, that voltage will be available right here. That means if you actually connect an oscilloscope right there, that's the voltage you will be looking at, 24.3 volts. So remember, what is the shape of the signal right here? So if the problem is asking for, okay, go ahead and draw the shape of the signal, remember this is a full wave rectifier. So that's the shape, and what's the voltage? So how much voltage is going to be right here? So what is this one? Peak output voltage. That means that's the voltage that is available right there. So this voltage is the one that we calculated is available all the way at the end of the circuit. So that 50 volts that we are saying, correct, which is when we start with finding out the secondary, correct? So this 50 volts is the secondary voltage. That means that's the total secondary voltage from top to the bottom, which is from here to here. That's 50 volts, correct? When you half it, that's only to the center tapped. And then when you take away 0.7, that's basically available right here, which is pretty much anywhere, either here or here. Both are combined here. Pretty much it's the same thing. So the 24.3, which is called as the peak output voltage. When we say output voltage, it automatically means it's at the end of the circuit. So when you feed in 100 volts peak, you effectively get 24.3 volts right at that resistor. So are we clear? So on the primary side, from top to the bottom, you have 100 volts. On the secondary side, from top to the bottom, you have only 50 volts. Because the remember transformer stepped down in here to 50 volts. So 1/2 would be 25. 25 minus 0.7 would be 24.3 volts. Yep. So that's at the output side, whether you have a resistor, whether you have a speaker, whatever you have it right there. But mostly we treat it as a resistor. Yeah.
So if the center leg somehow opens, the diode should get wrecked.
What you said?
If the center leg somehow becomes open, the diodes would then will be 50 volts on the diodes in either direction, and then be beyond the PIV value.
That's PIV. So once we find PIV, then we know what's the minimum rating we need to choose when we're purchasing these diodes.
I thought it was 50.1.
Yeah, whatever the value, we haven't calculated yet. So if whatever the value that you come out is, so it's saying PIV is 50.1. That means when you're purchasing it, we need to make sure that the breakdown is way higher than that 50.1. If it is 50.1.
2 times
So
24.3.
that's your second one is the PIV. So remember that the formula for PIV is, so it's 2 times V peak out plus plus 0.7, correct? So that's the formula for the PIV rating. So it's 2 times 24.3. It's the peak output voltage, and you add 0.7 to it. So 48.6 plus 0.7, I think it's like 49.3. So that would be, that comes around 49.3 volts.
Which, if the center leg opens, then you have 50 volts output, correct?
Yeah, if this is not a center tapped, then pretty much you can't use these diodes because the diode will see like 50 volts on them. Yeah. So when you're purchasing it, what?
Would that wreck the diodes?
It may not be initially, they may get overheated. What? No, his question was if something wrong happens onto the transformer itself. For example, somewhere in here, remember that this half should be only 25, correct? If that is 50, then what would happen to the diodes? So initially, then not necessarily they may get damaged, but definitely going to be excessive heat and eventually may damage.
What we say is, if that's your PIV, you'd be using diodes with a much higher value.
Yeah, you're going to use with a little bit higher than what that says.
So I think what happened is,
If you use 100, what?
If you get rid of the center tap, if you leave that leg open, if those diodes don't burn out, what you now have is a half.
It's a half, yeah, because you're not going to have any phase shift down there.
Which is no big deal. I mean, but if you short it out, open is not a problem. Short is a problem.
Yeah, it depends on the application, but this one, if you say 49.3 volts, then you choose a breakdown of 100 volts, then you're well within that range.
You just have some hot diodes.
Yeah, so you have some, remember that the actual value should be at least 20% or higher for safe usage. So
The PIV is pretty much, these diodes are rated to this.
yes, according to that circuit only. So if you build this circuit, that's the PIV for it.
One diode?
Yes. Of course, we use the same exact diodes for either one of them. So it's per diode pretty much. So when we're purchasing them, we need to make sure that their breakdown is a little bit higher than what that is. So if you buy like 100 volts breakdown, which is usually called as a reverse voltage, then it should be well within the safe range. Right. So again, that PIV is meant for that given circuit only. For example, if you raise the input voltage to like 120 volts or 240 volts like that, then effectively your PIV will be increased. Then you choose a different type of diodes. So it's for the given circuit. So any questions on this example? Again, the problem may ask for currents as well. For example, we all know, for example, if I know the resistor value, so let's say the resistor is, so resistor is maybe like 1K. If the problem also asks for, okay, what is the current flowing through the resistor, right? So what's the formula for current? So if we extend this problem, let's say it's asking for current as well. So the voltage on the resistor would be what? Your 24.3 volts. So all you do is you take that output voltage and you divide by whatever the given resistor is. So that's a simple in terms of an Ohm's law. So if it ever asks for currents, so how much current would have flown through the resistor? Because remember, the voltage right at the resistor is your output voltage, whatever that output voltage is.
So essentially, in order to find the VP out, first we need to find the VP of the secondary.
Yeah.
How a lot of the questions will be, I would assume.
Yes, pretty much, unless secondary voltage is given it to you, then you just use that. But if it's not, then you need to find the secondary voltage first. Yeah, the secondary over the primary times the input. Yeah. Yes, voltage all the way at the end of the circuit. Yeah. Yeah. First, based upon the turns ratio, you get the secondary. So once you know the secondary, and then you use the subsequent formulas. That's the case if you have a transformer, right? So even in the half-wave rectifier as well, like in the last class. Yes, V peak out is the voltage across the resistor, which is at the end of the circuit, right after the diode. The input voltage. So if you say VP in, that basically the input voltage, in this case, for example, the 100 volts voltage source. Yes. Yeah, the input voltage is input to the circuit. So we are feeding in 100 volts to this entire circuit. But effective full wave rectifier voltage we are getting is 24.3 volts.
Which is the primary, VP is the primary.
Yeah, input voltage. If you have a transformer, you can say primary. Yeah. Its input is whatever you are feeding in to the entire circuit. All right, so let's do another example of similar type of rectifier. So before we proceed to the next stage of the circuit, which would be the filtering stage. So all right, so this one would be the center tapped as well. So that means this would be the full wave rectifier as well. So the turns ratio is 3:1. The primary voltage is 150 volts RMS. So let's say what we are looking at is,
So in order to get peak to peak, we can multiply that by 1.414.
did you say peak? It's only peak. Did you say peak to peak?
that not be 212 peak to peak?
Again, we're not looking for peak to peak. We're only looking for peak.
Would that not be 106.2?
I need to calculate to see. So what did you do?
I did 150 times 1.414.
Yeah,
212.1.
that sounds about right.
Okay, that's peak, right?
Peak.
That's just peak.
Yeah, and that's what we are looking for too.
212.1. Divide that by 3. It gives us 70.7. 70.7 gives us 35.35 on each leg.
All right, so this is what we are looking at for this problem.
One with 18.375. That's for peak out.
Yeah, maybe. Yeah, I did look at. All right, so these are the 4 questions that the problem is looking for.
First we go for our next 2 peak. You're going fast. I can't do it myself. I have to watch you.
Which one?
The whole problem, whole forward.
Okay, I haven't started yet. I'm just waiting. So I'm just waiting here to see whether you got 0 volts or not. So the first thing you should start is converting into the peak voltage. Always, when you see an RMS, that's the first thing you should do is convert into the peak voltage. Yep. So this one is your peak, and over 3 would be okay. So this is the secondary. Okay. That's each half, correct? Then you don't have it again. This is only secondary over 2. So your secondary is 70.7. You're actually doing 1/4 rather than half. So this formula is only indicating V peak secondary here. So it's 70 over 2. And this is -7, correct? Minus 0.7.
So we calculate when we're going, that's the peak set.
Yes. So the first one is pretty much the V peak sec, which is the total secondary voltage. So you guys note down the problem, right? Okay. So the first thing you should do is you take this RMS voltage and you convert into the peak, right? So which is either you divide by 0.707 or multiplied by 1.414. So either way. So how much this should be? Like 212.6, 16, right? So this is the peak voltage, but this one is only the primary voltage, correct? So this is only the primary voltage side of the transformer. So it's a V peak primary only. So the first part of the problem is asking for calculate the secondary voltage. So the turns ratio is given as well. So that's a 3:1. So we are trying to find out the secondary voltage. So V peak secondary is, so that means 1/3, correct? So it's the secondary turns ratio value over the primary times your total primary voltage. So which is basically 1/3 of the primary rating. It's like 71. Yep, 70.72. So that would be the secondary voltage. So that means it's from here all the way to here. So for the entire secondary side of the transformer. So what would be the number 2? What is it? So it's across each half of the secondary, right? So each half of the secondary would be basically 1/2. So which is your, so it's simply 1/2 of the entire secondary voltage is, so that's 70 over 7.2, sorry, 70.72 over 2, that's 35.36, right? Or 35.36. So this is, again, this is 1/2, so that's pretty much only this part, which is of course the voltage that are feeding to the diode itself, right? Yeah. Yeah, so that would be your V peak out. If you subtract 0.7 from this, then that's after the diode, which is your V peak out. So, but the problem is not asking for V peak out, doesn't it? But it's asking for the current through the diode, which is going to be same, because when this diode starts conducting, this diode appears to be in series with resistor. So the problem can be worded like this as well, rather than just asking for, okay, what is the current flowing through resistor? You could also say it's the same current flowing through the diode, because if diode allows the current, it will go through the resistor. So even though it's not specifically asking for the output voltage, you still have to find that output voltage, because the problem is asking for the current. So the V peak output voltage, you can either use that straight formula, which is V peak secondary over 2 minus 0.7, right? So if you stick to that formula, so that's 70.72 minus or over 2 minus 0.7, or you can simply say, because 1/2 is already, we already found out that 1/2, correct? So, and you just take away 0.7 from it. So either way you will get the same results. So 1/2 is that, and you take away that 0.7. So how much that would be? So 34.66. So that's at the diode pretty much. So after the diode is when you take away 0.7, which is pretty much right here, which is same as, which is pretty much connected to the resistor. So it is the voltage on the resistor as well. So now you can find the current from it. Yeah, so you can find the current is you simply take that output voltage and use Ohm's law. So it's a V over R. So it's like 34.66 milliamps when you do calculate the current. So yes,
I was actually, now see it has two diodes right there.
yes.
Why wouldn't the diodes be, you know, like when you're
Remember, at any given time, how many diodes are forward bias?
No, it's turned off.
Remember, only one diode is going to be forward bias at any given time. So that's why you take away 1.7 only, right? Because
always
in this circuit, so it's not always going to be like that, because if you take half wave, does half wave has two diodes? So, but if you look at bridge, which is coming next, then you will get a 1.4 where two diodes are being conducting rather than one diode. So that would be the number 3. So even though it is asking for the current flowing through the diode, but you would have to find the output voltage. After this, the PIV rating is pretty much substitution.